Hello and welcome to Maths Alberta today. How are you doing today? I'm happy to see you in this class. Please ensure you stay put, relax, as we enjoy a form of coding section together called Ellipse. Okay, so without wasting time, what I'm holding is a circle, for example. Is a circle. If you look at it very well, it's a circle. Now, if I stretch, look at it. If I stretch this circle like this, you will get an oval shape. That whole kind of oval shape is what we call an ellipse. Look at it. This is a horizontal ellipse. Look at it. If you stretch it this way, let me keep it straight. If you stretch it this way, you get a vertical ellipse. Okay? Now let's have this. Let's have this together. Look at what we are seeing. Look at the shape you are seeing. I stretch a circle horizontally like this. I get an oval shape which is called a horizontal ellipse. Okay? Now let's enjoy it together. Please stay put as we enjoy it together. Now, the end point of an ellipse has before we solve that question, an ellipse has 4 vertices and 2 foci. What do I mean by that? This end point here is a vertex. Let's start with this one. Let's call it here V1. The coordinate is, if you measure from here, this is the center of the ellipse actually. If you move from here to this place, is assumed that you have covered a sort of A distance along the x-axis. Let me take away this. So you cover some sort of A distance along the x-axis. Since it's around the x-axis, y coordinate is 0. Here, the same point, if you come over here, this is like V2, the coordinate is a negative A and then 0. For example, this is the second vertex. Now we have 2 more vertices. Call this one here, where it intersects this other side. Call here V3. The coordinate here is now, you use letter B now. This is 0, B, a sort of B distance from the origin. Now, if you look here, if you go down here from the center to this point, you're going to have another vertex called V4. The coordinate is now 0, negative this. Now, there is another point, or there are 2 points from away from the center called the foci. If you move from here to here, let's say you cover a sort of C distance. A is bigger than C actually. So here, let's call here F1, which represents the first focus. All right, and here you have the coordinate of this place is C, 0. This place here, move away from here towards the vertex. Let's have the second focus, which is a negative C from 0. So, without wasting time, an ellipse is saying that these 2 fixed points, we call them, each one is called focus. In the plural of focus is called foci. Alright, so ellipse is saying that, ellipse as a coding section is saying that to these 2 fixed points called the foci, plural, if you move from here, for example, to one part of an ellipse, and you take the movement from the second part of the focus down to the other same part, they are saying that by the time you add these 2 distances together, you are going to get a constant. What do I mean by that? Like, let me call here P, you have x1, you have xy. Now look up here. See what we are saying? We are saying that as far as ellipse is concerned as a conic section, we are saying that the distance from, if you move from, look at it, if you move from P, let's say F2 to P, this distance plus the movement from F1 to P is going to give you a sort of constant, which is the value. It's going to give you a value. They are not the same actually. Movement from F1 to P and F2 to P, the distances are not the same, but the sum of their distances is equal to a constant. This is what we call an ellipse. Okay, so let's answer that question together. Now, equation of an ellipse depends on the major axis where the circle is stretched to get an ellipse. All right, so one of the equation is x squared over a squared plus y squared over b squared is equal to 1. Now, where a is greater than b. Now, a is always bigger than, greater than, or bigger than b. That's when you know the major axis of the ellipse. So, if you see a bigger value under s squared, you know that the ellipse or the circle that was that the ellipse was gotten from was stretched along the horizontal axis. Now let's go. Let's go and fetch that question. Okay. The question says, let's go and get the question so that we can handle it together. So we have x squared over 100 plus y squared over 64. Okay. So let's have that. All right. So let's answer that question together now. We're going to have x squared over 100 plus y squared over 64 is equal to 1. Now, if you check very closely, you discover that the bigger value is serving as the denominator of the x squared. So that means that the ellipse, the major axis of the ellipse is around the horizontal axis. So we are going to compare this with the general equation of an ellipse when it is stretched along the horizontal axis. This is the equation of the ellipse. When the axis of the major axis are around or along the horizontal axis. So let's compare now. So by comparison, let's say by comparison, okay. So let's say by comparison, or let's say compare x squared over 100 plus y squared over 64 is equal to 1. Compare it with x squared over a squared plus y squared over b squared equal 1. So if you do the comparison closely, you discover that, what will you discover? You will discover that a squared is equal to 100, which means that what? Here, take square root of both sides. If you bring it out, okay, let's bring out the second equation first. The second equation says what? B squared. If you do the comparison very well, see what will happen? If you compare very, very well, see what will happen? This one is equal to this a squared, and then 64 is equal to this b squared here that I wrote here. Okay, now let's go back and finish up. Then b squared is equal to 64. Now, here, what do? Take square root of both sides. So, square root of a squared is equal to the square root of 100. And which means that what? This means that, okay, let me just write them one by one so that we don't, okay. Now, here, this means that a is equal to plus or minus 10 as the answer. Now, if you do the second comparison, you have b squared is equal to 64. Do a similar thing, take square root of both sides. If you do that, we are going to have b squared, you have square root over it, is equal to what? Square root of 64, for example. Square root of 64. Alright, that means that b is equal to plus or minus 8. Okay, so we have found the information that we need to get the vertices from. Is remaining. Okay, let's write out the vertices first before we talk about the foci. All right, so the vertices of the ellipse in question. Okay, there are 4 vertices actually. So V1 is represented by a, 0. That implies that V1 in this case, what are the values of a? Plus or minus 10. So we can have plus 10 and then 0. V2, which is the second vertex, is negative a, 0, meaning that V2, if you replace, you are going to get a negative 10, then 0. Okay, 2 more to go. V3 is actually, this is where B comes to play now. So we have 0, B, which implies that what? Which implies that V3 is actually 0, 8. 0, 8. Now, V4 is 0, negative b, which means that V4 is actually 0, negative 8. So these are the 4 vertices of the ellipse in question. Now it's remaining the 2 foci, those 2 fixed points. Remember, foci is represented by letter C, and there's an equation that connects A, B, and C together. Now let's go. So we are going to say, let me write that in another color. We are going to say, recall that we need the value of C actually. That C squared, which will help us get the foci of the ellipse, is actually equal to A squared minus B squared. That's because A squared is always greater than that of B squared. Alright, now let's go. So we're going to say C squared is equal to A squared used to be 100 from the beginning of the question. When we did the comparison, look at it. A squared is 100 and B squared is 64. So let's take them. So minus B squared is 64. Now, C squared is equal to 100 minus 64, you get a 36. Alright, take square root of both sides. If you do that, you have square root of C squared is equal to the square root of 36. Alright, meaning that what? That C is equal to plus or minus 6. Alright, plus or minus 6 means that C is 6 or C is equal to minus 6. Now, that means that the 2 foci of the ellipse, F1, represented by C, 0, will now become F1, and then replace the first value of C, you have 6, 0. Second focus is actually a negative C, 0, which if you do the replacement where you have F2, a negative 6, 0. So these are the 2 foci of the ellipse given, and the other one here, this one here, are the 4 vertices of the given ellipse. Okay, so this is what we do when you are given a question of this kind. All right. So let me give you something for you to try. Remember, ellipse can be stretched in 2 ways. Either you stretch it like this, you have an oval shape, we call it a horizontal ellipse, or you stretch it like this towards vertically like this. We call it a vertical ellipse. Okay, let me give you something similar to this for you to try for me. Please, when you are done, ensure you fix the answer in the comment section. So this is for you. So find the 4 vertices and foci of the ellipse. This is a description of the ellipse. So please, when you are done, I want to see your answer in the comment section. Please do well to like, to share, to subscribe, to follow if you are here to do so. Please remember to tell somebody about Math Albatoire. God bless you.